All right, so I want to talk about multi-scene physics. Let me get a share screen going. So multi-scene physics. Originally, Unity just had a single scene in which physics was calculated. In Unity 2.18, they give us the opportunity to have more than one scene active, kind of overlaid on top of each other, with separate physics going on in the different scenes. Objects in one scene don't collide with objects in the other. And you can even do crazy things with the time scales. One application of this is the ability to predict trajectories without committing to them. And I'll show you an example of this. But first, let's do a very simple setup. So I have two scenes, main and alternate. In main, I have a ramp that's tilted a bit and a ball that falls and rolls down. And in alternate, the ramp slopes a different direction and the ball starts a different place. And both of these are included in the build settings. So my build settings include the main and the alternate. Main should be first, and the alternate scene, it's sloping the other way. The alternate scene has no lights or cameras, and the main needs to have an object with a physics loader script on it that in start will load the alternate scene. And this is done additively and with this special local physics mode, physics 3D, so that it loads with a separate physics engine. Very simply playing this here, when I play it, I can now see both scenes. The two balls roll different directions. They don't collide with each other, but they're both obeying separate physics engines. So this is pretty cool. One thing to note in that scene loader script, I also need to trigger the simulation of the alternate physics scene. And this is done in the fixed update function where I call the physics scene simulate with a time step, and one with physics scene time scale equal to 1. These two physics simulations will go on at the same rate. If I were to change that scene time scale, I could make one scene run slower or faster than the other one. So I want to apply this to my a game where we want to be able to kind of see ahead of time what our shot's going to look like. What is the result of shooting something? And I'm going to do this with a billiards game, a pool game. And I got the basic framework for this from Ditzel's 1 hour billiard game. And I have modified it considerably from what he originally posted, but it's fundamentally his game. Now, a number of things I found was that in order to maintain synchronicity between the two scenes, it's important that the manager has information about the objects in both of the scenes. I'm going to have a game manager that manages both the ghost, the trial shot, and the real objects. And so to keep these things all separate, I'm going to use custom tags that I can find game object or objects with tag to locate these various objects. And I'll have custom tags for the cue, the real cue ball, the real balls, a real line, and those are all main scene objects. and then I'll have ghost cue and ghost ball for the alternate scenes objects. The game manager is going to control the aiming and firing of the respective cue balls that then go on to hit various normal balls in both scenes with various public and private variables. I've got a force multiplier to kind of tune how strong my shot is, various UI elements, hit text and strength text. A public bool is moving that's actually more for debugging purposes. And then all these various privates for the different game objects, the real and ghost cue, the arrays of real balls and ghost balls, various rigid bodies that I need to access, hits for the scorekeeping mechanism. And I'm also going to do that physics scene loader stuff here in the awake function. I'm doing it in awake so that it happens before any starts because various objects that start later, this way we're ensured that the scene is active and ready to go before we start looking for various objects with the tag. This turned out to be quite important. Also, there's the fixed update with the scene simulate. Let me show you what this looks like. So I have a kind of top-down view of my pool game. If I do the right mouse button, it fires the ghost cue, shows me the positions of the balls. And if I press the left mouse button, it fires both of them. And I can shoot my cue ball around and do the various physics and presumably sink balls. There I missed, and I can keep adjusting this until I hit. Well, anyway, you get the idea. I'll let you play with this at your leisure. So in start, I'm going to find all the various objects with find out game object with tag, the real line, the cue, the ball, those are the real objects, and the ghost cue and the ghost ball in the alternate scene. Get the line renderer, extract various components from the different objects, in particular the rigid bodies of the real and ghost cues and of the real and ghost balls, turn off the line renderer and set up the UI. I have a function test if moving to see if the balls, and in this case, both the real and the ghost balls have stopped moving. And I do this by looking for when the balls are sleeping. The rigid body is sleeping, tests to see whether the balls have stopped moving and gone to sleep. If this returns a true, balls are moving. If it returns a false, all the balls are sleeping. The update function is where most of the work goes on. And first of all, it has a bailout. If the balls are moving, it immediately returns. Otherwise, it turns on the line renderer so that we can see our position, cast a ray cast out into the scene to get the mouse position, which I'll use for the hit point, setting the various positions on my line so that it represents that arrow between the two things, and establishing what I want the strength to be based on the length of that line. Depending which mouse button is pressed, I either fire both of them. That'd be the left mouse button where I apply this impulse with an add force, or if the right mouse button, I only fire the ghost. And both of these are followed by a call of a coroutine restore old position that puts the ghosts back where they belong, or else it resyncs them to account for slight differences in physics between the two different simulations. They are meant to be identical, but physics being what it is, they don't always maintain exactly identical positions. So restore old position waits a bit. It turned out I needed to do this so that the balls could start moving before I started testing. Then it spins on the test if moving function so it doesn't restore the positions until everyone has come back to rest. And then it goes ahead and resets the positions of the various ghost cues and ghost balls. And I found it was necessary to reset both their position, rotation, velocity, and angular velocity. Otherwise, they carried momentum with them. Although since they were asleep, I probably don't need to do that. And finally, there's a reset function that's invoked from one of the UI buttons that reloads the scene for replay. So that's the gist of this. I can test what a different shot will do, and then it resets them, and I can actually fire the ball and sink the ball. The strength is indicated up here in the UI, and how many shots I've taken are counted as the balls move. The ghost shots don't count against your shots, so we can test as many ghost configurations as we want to until we get a shot that we like, and then we can do the real shot. So I'll let you play with this, and I had a lot of fun with this. It's a really interesting mechanism for Unity. So I'll stop the sharing here, and I'm going to end recording, and I'll see you all in class. Bye.